section 2.2. We're going to talk about conditional statements. So chapter 2 is all about logic. And the reason that we study logic in geometry is, one, historically geometry is one of the first places where math, information about math was built up using just logic. So we're kind of following that path. And two, we're trying to what a lot of what we do with math in general is use logic to figure out what things have to be true if we know certain other things. So we're kind of building that toolbox. And logic is also good to know because lots of people try to use logic, or what seems like logic, to convey information, to give you information, especially when they're trying to sell you something. They try to make it seem logical even when it's not. Politicians like to speak as if they're using logic. Sometimes they are, sometimes they're not. So it's good to know something about logic. But today we're learning something about our vocabulary. Conditionals is our first. We're going to say conditional. We use the word conditional, and we kind of use it interchangeably with conditional statement. So I'm going to put statement in parentheses. A conditional statement is a statement that we write in the form if and then. So we're going to say an if then statement. So an example would be, if it is raining, I carry an umbrella. But then I use an umbrella. So that would be an example of a conditional or a conditional statement. Something with an if and a then. In symbols, we write it this way, with a little arrow. And we read this: if P, then Q, where P is some statement, some phrase, and Q is some other phrase, some other thing that we're interested in. Or we could also read this as P implies Q. Those two mean the same thing. If P then Q and P implies Q mean the same thing. We call the part the hypothesis is the part of P that doesn't include the if. So I'm going to say the part of P after if. So we don't include the word if. So the hypothesis of this conditional statement is it is raining. And then the other part is the conclusion. That's the part of Q after then. So the conclusion of this conditional statement is I use an umbrella. We don't include the if and the then with our hypothesis and our conclusion. And we can also write this in a diagram. We call it a Venn diagram. Sometimes you'll see them called an Euler diagram. Venn diagram for this conditional statement is P is inside and Q is in the bigger circle. If I'm inside the circle with the P, then I'm also inside the bigger circle with the Q. So this is the same as if P then Q. And for the conditional statement that we wrote before, it would be raining and umbrella. So that would be the Venn diagram for this conditional statement. If it is raining, then I use an umbrella. And what we're going to do today is work with conditional statements, talk about when they're true or false, and then we're going to talk about the relatives of this conditional statement. Some relatives. All right, are we good so far? Now the one downside of chapter 2 in geometry is there are a lot of words. So I'll tell you that right up front. We're going to talk about a lot of words, and we use a lot of words to describe logic. All right, so let's decide. I want to do a couple of examples. Let's decide if these conditional statements are true. If a number is even, then it is divisible. Folks, phones, put them away, please. Then it is divisible by 2. Is that a true statement? Yeah. The number is even, it has to be divisible by 2. So this is true. So that conditional statement is true. Let's write this next one as a conditional. Adjacent angles share a side. So how can we write that statement as a conditional statement? Conditional statement has an if and a then, so we want to say if two angles are adjacent. Okay, that works. Then they share a side. We could write it the other way around also. If two angles share a side, then they are adjacent. And we'll talk a little bit more tomorrow about what happens when we can write it in both ways and they're both true. All right, so that's writing this as a conditional statement. If two angles are adjacent, then they share a side. Is that true? Yeah. That's how we said. That's what makes angles adjacent. They have to share a side. Well, let's see. Is that necessarily true? How about? I'll see if I can think of a counterexample. Let's see. No, I'm not sure that's going to work. Two angles are adjacent and they share a side. I was thinking of something like this. These two angles, this angle and this angle share, but they only share part of this ray, right? I'm not sure that would be a counterexample. Okay, never mind. All right. The truth value. We talk about the truth value of conditional statements. The truth value just means, is it true or false? So a conditional statement can only have one or the other. So it's just a true or false. A conditional statement can't be halfway between those, one or the other. So there's only two possible truth values, and to show that a conditional is false, what do we need to do? Think about our opener. I could say for our opener, if we add two numbers together, then the sum is greater than either. We find a counterexample. To show a conditional is false, find a counterexample. And the nice thing about counterexamples is we only have to find one. We don't have to find a bunch to show that a conditional is false. We just find one counterexample. And that shows that our conditional is false. So let's practice here for a second finding counterexamples, or deciding the truth value of a couple of conditional statements. So our conditional statement can be either true or false. To show this false, we find a counterexample. So example, if you live in Miami, then you live in Florida. So we want to find the truth value of this, and if it's false, if we think it's false, we need to find a counterexample. So is this true or false?
True.
True?
True.
Okay.
Miami's in Florida.
Miami's in Florida.
Well, I had to say why it's true.
But what if I said, here's my question. What about Miami, Ohio? I've been in Miami, Ohio.
I didn't know that existed.
There's a town in Ohio called Miami. So would that be a counterexample?
Yeah.
Yeah. So if we knew that there was a town in Ohio called Miami, that would be our counterexample. I don't think a lot. Someone in the other class knew that there was a Miami, Ohio, and I've actually been to Miami, Ohio. There's a color. So Miami, Ohio would be a counterexample. I think most people would say this is true. All right. How about if a number is divisible by 5? Then it is odd. False? What would be a counterexample to this? 10. 10? Others? 20, 30, 40? Any of those would be a counterexample. That these numbers are even, but they are divisible by 5. So that would be a counterexample. Any of those would be a counterexample. Yes? So we're saying a conditional statement is true only if it's true always. So if it's false even once, then we're going to say it's false. All right. Are we good with truth value and counterexamples?
We only need a counterexample if it's false.
Now, often what we'll have to do what we do with a conditional statement that we think is true. Does anybody remember from the video if something that we think is true, what that's called?
All 7 of you.
All 7 of you? We call that a conjecture. So if we make a conjecture, we think this conditional statement is true, then we have to prove that it's true. We have to prove that it's true always. So, and we'll do some of that a little later. All right. Next, we're going to talk about some relatives of conditional statements. But first, we need to talk about the negation. And just based on the word and the base of the word, what are we going to guess that negation means? Negative. And if we're saying if it's something that we're some kind of statement, what is the negative of a statement? The opposite. We're talking about the opposite. The negation of something is the opposite. So when we say form the negation, we mean form the opposite. We write the negation with a little squiggle. So a little squiggle, and we say that not P. So that is the negation of P, not P. So if we were to say that the sky is blue, the negation, the sky is not blue. So this would be the negation of this statement. We're saying the opposite. And what we're going to do is use negation to write some statements that are related to conditionals. So let's start with our original conditional and write our relatives. So our conditional statement is if P then Q. So that's our original conditional statement. The converse is a relative. The converse of the conditional statement is we just switch the two around. So we just switch the order. And we would read this, if Q then P. So to make the converse, we just switch the order. The inverse we make with a negation. We put not before P and Q in the original conditional. So we're going to say not P implies not Q. And we would read this, if not P, then not Q. And putting not in front of the P and the Q, we call negating P and Q. So we could say to make the inverse, we negate P and Q in the conditional statement. And then our last relative is called the contrapositive. And our contrapositive is the negation of the converse. So for this, we're going to put not in front of the P and the Q in the converse. And we would say this, if not Q, then not P. So those are our relatives of our original conditional statement. Our conditional, if P then Q. The converse, we switch the order. The inverse, we make the negation. of the conditional, we put a not in front of the P and a not in front of the Q. And the contrapositive, we form the negation of the converse. Put a not in front of the P and the Q in the converse. And the reason these are important is that the truth value of a conditional and the contrapositive are the same. So if the conditional is true, then the contrapositive is true. And the truth value of the inverse and converse are the same. So if the inverse is true, then the converse is true, and vice versa. If the inverse is false, then the converse is false. So these are important. These are important because a lot of times when people use logic, you form the converse or you form the inverse, and then you want to figure out some things based on that. So we need to know about the truth values of the inverse and the converse and the contrapositive, and how they relate to the original conditional statement. All right, so the last thing I want to do is just practice forming. Start with a conditional statement, form the converse, form the inverse, and form the contrapositive. All right. So we'll use this example a lot during this school year because it's easy to figure out, easy to think about things in terms of this. So I'm going to say, if you are a math teacher, then you know algebra. All right. Would we say this conditional statement is true? Yeah?
Yeah.
Yeah. If you're a math teacher, you have to take a big, long test, and a good part of it is algebra. So you have to know algebra to be a math teacher. So we're going to say this conditional statement is true. All right. So let's form the. Oh, and if we drew a Venn diagram for this, just so we have an example. Middle would be teacher, and then algebra. If you're a teacher, then you know algebra. And we're talking about a math teacher here. So. All right, let's form the converse. So to form the converse, what do we do with our hypothesis and conclusion? Switch the order. So if we switch the order, we're going to say if you know algebra, then you are a math teacher. They would switch around too. Is this conditional statement true? No. What would be a counterexample? Us. Everyone in this class, right? You guys learned algebra. Everybody passed Algebra 1. So you should know algebra. You may not know all of algebra, but you know algebra. But you're not math teachers. So the counterexample would be this class. Or any person in this class. And our Venn diagram, if we drew a Venn diagram for the converse, our two things would just switch places. So we would have algebra, and math teacher. And this is not necessarily true. All right, let's form the inverse. So to form the inverse, we want to negate the original conditional. So how are we going to negate the original? If you were not a math teacher, then you do not know algebra. Correct. And is this conditional statement true? If you are not a math teacher, then you do not know algebra. Maybe you do. What would be a counterexample?
Us.
Us, again. You guys are not math teachers, but you know algebra. So a counterexample is this class. So that's our inverse. If you're not a math teacher, then you don't know algebra. And notice that the converse and the inverse have the same truth value. They were both false. All right, let's form the contrapositive now. So the contrapositive is the negation of the converse. So how are we going to form the negation of the converse? If you don't know algebra, then you are not a math teacher. And is this conditional statement true? If you don't know algebra, can you be a math teacher?
Yes. Part of the test.
So would this be true? If I don't know algebra, then you are not a math teacher.
Yes.
That is true. If I don't know algebra, they don't allow you. If you don't know algebra, they don't allow you to be a math teacher. So this is true.
Depending on what level we are.
I guess if you teach elementary school, but then you wouldn't be a math teacher. You'd just be an elementary school. So you could be an elementary school teacher and not know algebra.
Well, I just got one math teacher.
You had a specific math teacher? Huh. I only had one teacher, like per grade in elementary school. So that's interesting. So that would be, would that be a counterexample to this? Did your math, or he or she not know algebra?
I don't know.
You don't know. So it's possible, right?
It is possible.
Yeah. So that's possible that would be a counterexample. That's a good point.
Then you were very simple.
Right. All right. Yeah, the test for elementary school teachers are a little different than the test for high school teachers. But not a lot for the math. Yeah, it is a little different. And notice that for our assumptions, the contrapositive is the same truth value as the original conditional. So the contrapositive and conditional are the same. The inverse and the converse are the same. One last thing. If the conditional statement is true, the converse is not necessarily true. So in our example, the conditional statement is true and the converse is not true. Tomorrow we'll talk about something special that happens when the inverse and converse when the conditional statement and the converse are both true. There's something special that happens. And one logical mistake that people often make, especially when they're trying to sell you something, especially when they're trying to convince you of something, is to assume that the converse is true if you know the conditional is true. That's one mistake that people will make. All right, questions? So your homework tonight is going to be figuring out truth values, forming inverses, converses, contrapositives, forming negations. So that's what tonight's homework is all about. So our homework, page 93. No, there were problems that we had to do as well. All right, there's the homework.